camcorder is an electronic device combining a video camera and a video recorder, typically used for consumer video recording. Although marketing materials may use the colloquial term camcorder, the name on the package and manual is often video camera recorder. Most devices capable of recording video are camera phones and digital cameras primarily intended for still pictures. The term camcorder is used to describe a portable, self-contained device, with video capture and recording its primary function. The earliest camcorders were videotape-based, recording analog signals onto videotape cassettes. In the 21st century, digital recording became the norm, with tape replaced by storage media such as internal flash memory and SD cards. History. Video cameras originally designed for television broadcast were large and heavy, mounted on special pedestals and wired to remote recorders in separate rooms. As technology improved, out-of-studio video recording was possible with compact video cameras and portable video recorders. A detachable recording unit could be carried to a shooting location. Although the camera itself was compact, the need for a separate recorder made on-location shooting a two-person job. Specialized video cassette recorders were introduced by Vhs-C and Sony, releasing a model for mobile work. Portable recorders meant that recorded video footage could be aired on the early evening news, since it was no longer necessary to develop film. In 1982, Sony released the Betacam system. A key component was a single camera recorder unit, eliminating a cable between the camera and recorder and increasing the camera operator's freedom. The Betacam used the same cassette format as the Betamax, and became standard equipment for broadcast news and in-studio video editing. Sony released the first consumer camcorder in 1983. The Betamovie BMC100P used a Betamax cassette and rested on the operator's shoulder, due to a design not permitting a single-handed grip. That year, Vhs-C released the first Vhs-C camcorder. Sony introduced its compact Video 8 format in 1985. The Vhs-C and Video 8 formats have been reported as equally successful. That year, Panasonic, RCA and Hitachi began producing camcorders using a full-size VHS cassette with a 3-hour capacity. These shoulder-mount camcorders were used by videophiles, industrial videographers and college TV studios. Full-size Super VHS camcorders were released in 1987, providing an inexpensive way to collect news segments or videographies. Sony upgraded the Video 8, releasing the Hi 8 in competition with the SVHS. Digital technology emerged with a Sony D1, a device which recorded uncompressed data and required a large amount of bandwidth for its time. In 1992, Ampex introduced DCT, the first digital video format with data compression using the discrete cosine transform algorithm present in most commercial digital video formats. In 1995, Sony, Vhs-C, Panasonic and other video camera manufacturers launched DV, which became a de facto standard for home video production, independent filmmaking and citizen journalism. That year, Ikegami introduced Editcam. High definition, Panasonic launched DV-C Pro HD in 2000, expanding the DV codec to support high definition. The format was intended for professional camcorders, and used full-size DV-C Pro cassettes. In 2003, Sony, Vhs-C, Canon and Sharp introduced HDV as the first affordable HD video format, due to its use of inexpensive mini-DV cassettes. Tapeless. Sony introduced the XDCAM tapeless video format in 2003, introducing the professional disc. Panasonic followed in 2004 with its P2 solid-state memory cards as a recording medium for DV-C Pro HD video. In 2006, Panasonic and Sony introduced AVC HD as an inexpensive, tapeless, high-definition video format. AVC HD camcorders are produced by Sony, Panasonic, Canon, Vhs-C and Hitachi. In 2007, Sony introduced XDCAM-X, with similar recording modes to XDCAM HD but recording on SXS memory cards. 3D, in 2010, After the success of James Cameron's 2009 3D film Avatar, full 1080p HD 3D camcorders entered the market. With the proliferation of file-based digital formats, the relationship between recording media and recording format has declined. Video can be recorded onto different media. With tapeless formats, recording media was storage for digital files. In 2011, Panasonic released a camcorder capable of shooting in 3D, the Hdc Sdt 750. It is a 2D camcorder which can shoot in HD. 3D is achieved by a detachable conversion lens. Sony released a 3D camcorder, the Hdr TD10. The Sony's 3D lens is built-in, but it can shoot 2D video. Panasonic has also released 2D camcorders with an optional 3D conversion lens. The Hdc Sd90, Hdc Sd900, Hdc TM900 and Hdc HS900 are sold as 3D-ready 2D camcorders, with optional 3D capability at a later date. 4K Ultra HD. In CES 2014, Sony announced the first consumer camcorder Sony Fdr Ax100 with a 1-inch 20.9 MP sensor able to shoot 4K video in 3840x2160 pixels 30 fps or 24 fps in the XAVCS format. In Full HD shoot the camcorder can also deliver 60 fps. When using the traditional format AVC HD, the camcorder supports 5.1 surround sound from its built-in microphone. This is however not supported in the XAVCS format. The camera also has a 3-step ND filter switch for maintaining a shallow depth of field or a softer appearance to motion. For 1-hour video shooting in 4K, the camera needs about 32 GB to accommodate a data transfer rate of 15 bits. The camera's MSRP is $2,000. In 2014, Sony released the Fdr Ax100, which represents the next generation of camcorders. It is capable of shooting in 4K resolution, 4 times that current generation camcorders are capable of. It currently has a hefty price tag of £1,699, and 4K camcorders are not expected to come into the mainstream market for at least another 8 to 10 years, as most current Blu-ray players are not capable of playing 4K video. Virtually all mainstream TVs are not 4K ready either, with the only 4K TVs available being very expensive at £2,500 or over. Currently the only means of archiving 4K video is the 100 GB Blu-ray Disc XL, but the discs are very expensive. Components: camcorders have 3 major components: lens, imager and recorder. The lens gathers light, focusing it on the imager. The imager converts incident light into an electrical signal. The recorder converts the electrical signal to video, encoding it in a storable form. The lens and imager comprise the camera's section. Lens: the lens is the first component of the light path. Camcorder optics generally have one or more of the following controls: aperture regulates exposure and controls depth of field, zoom, controls focal length and angle of view, shutter speed, regulates exposure to maintain desired motion portrayal, gain, amplifies signal strength in low light conditions, neutral density filter, regulates exposure intensity. In consumer units, these adjustments are often automatically controlled by the camcorder, but can be adjusted manually if desired. Professional-grade units offer user control of all major optical functions. Imager: the imager converts light into an electrical signal. The camera lens projects an image onto the imager surface, exposing the photosensitive array to light. This light exposure is converted into an electrical charge. At the end of the timed exposure, the imager converts the accumulated charge into a continuous analog voltage at the imager's output terminals. After the conversion is complete, the photosites reset to start the exposure of the next video frame. Recorder: the recorder writes the video signal onto a recording medium, such as magnetic videotape. Since the record function involves many signal processing steps, some distortion and noise historically appeared on the stored video. Playback of the stored signal did not have the exact characteristics and detail as a live video feed. All camcorders have a recorder controlling section, allowing the user to switch the recorder into playback mode for reviewing recorded footage, and an image control section controlling exposure, focus and color balance. The image recorded need not be limited to what appeared in the viewfinder. For documenting events, the field of view overlays the time and date of the recording along the top and bottom of the image. The police car or constable badge number to which the recorder was given, the car's speed at the time of recording, compass direction and geographical coordinates may also be seen. Types: analog and digital. Camcorders are often classified by their storage device. VHS, Vhs-C, Betamax, Video8 are examples of 20th-century videotape-based camcorders which record video in analog form. Digital video camcorder formats include Digital 8, Mini DV, DVD, hard disk drive, direct-to-disc recording and solid-state, semiconductor flash memory. While all these formats record video in digital form, Digital 8, Mini DV, DVD and hard drives are no longer used in the latest consumer camcorders. In analog camcorders, the imaging device was based on vacuum tube technology, in which the charge of a light-sensitive target was directly proportional to the amount of light striking it. The Vidicon was an example of such an imaging tube. Newer analog and all-digital camcorders use a solid-state charge-coupled imaging device or a CMOS imager. Both are analog detectors, using photodiodes to pass a current proportional to the light striking them. The current is then digitized before being electronically scanned and fed to the image's output. The main difference between the two devices is how the scanning is done. In the CCD, the diodes are sampled simultaneously, and the scan passes the digitized data from one register to the next. In CMOS devices, the diodes are sampled directly by the scanning logic. Digital video storage improved its quality. Mini DV storage allows full-resolution video, unlike analog consumer video standards. Digital video does not experience color bleeding, jitter, or fade. Unlike analog formats, digital formats do not experience generation loss during dubbing. However, they are more prone to complete loss. Although digital information can theoretically be stored indefinitely without deterioration, some digital formats place tracks only about 10 micrometers apart. A digital recording is more vulnerable to wrinkles or stretches in the tape which could erase data, but tracking and error correction code on the tape compensates for most defects. On analog media, similar damage registers as noise in the video, leaving a deteriorated video. DVDs may develop DVD rot, losing large chunks of data. An analog recording may be usable after its storage media deteriorates severely, but slight media degradation in digital recordings may trigger an all-or-nothing failure. The digital recording will be unplayable without extensive restoration. Recording media. Older digital camcorders record video on microdrives, hard drives and small DVD-RAM or DVD-RS. Newer machines record video on flash memory devices and internal solid-state drives in MPEG-1, MPEG-2 or MPEG-4 format. Because these codecs use interframe compression, frame-specific editing requires frame regeneration, additional processing and may lose picture information. Codecs storing each frame individually, easing frame-specific scene editing, are common in professional use. Other digital consumer camcorders record in DV or HDV format on tape, transferring content over FireWire or USB 2.0 to a computer where large files can be edited, converted and recorded back to tape. The transfer is done in real time, so the transfer of a 60-minute tape requires 1 hour to transfer and about 13 gigabytes of disk space for the raw footage. Consumer market. Since the consumer market favors ease of use, portability and price, most consumer-grade camcorders emphasize handling and automation over audio and video performance. Most devices with camcorder capability are camera phones or compact digital cameras, in which video is a secondary capability. Some pocket cameras, mobile phones and camcorders are shock, dust and waterproof. This market has followed an evolutionary path driven by miniaturization and cost reduction enabled by progress in design and manufacture. Miniaturization reduces the image's ability to gather light. Designers have balanced improvements in sensor sensitivity with size reduction, shrinking the camera imager and optics while maintaining relatively noise-free video in daylight. Indoor or dim light shooting is generally noisy, and in such conditions artificial lighting is recommended. Mechanical controls cannot shrink below a certain size, and manual camera operation has given way to camera-controlled automation for every shooting parameter. The few models with manual override are menu-driven. Outputs include USB 2.0, composite and S-video and IEEE 1394/Firewire. The high end of the consumer market emphasizes user control and advanced shooting modes. More expensive consumer camcorders offer manual exposure control, HDMI output and external audio input, progressive scan frame rates and higher quality lenses than basic models. To maximize low light capability, color reproduction and frame resolution, multi-CCD CMOS camcorders mimic the three-element imager design of professional equipment. Field tests have shown that most consumer camcorders produce noisy video in low light. Before the 21st century, video editing required two recorders and a desktop video workstation to control them. A typical home personal computer can hold several hours of standard definition video, and is fast enough to edit footage without additional upgrades. Most consumer camcorders are sold with basic video editing software, so users can create their own DVDs or share edited footage online. In the first world market, nearly all camcorders sold are digital. Tape-based camcorders are no longer popular, since tapeless models cost almost the same but offer greater convenience. Video captured on an SD card can be transferred to a computer faster than digital tape. None of the consumer-class camcorders announced at the 2011 International Consumer Electronics Show recorded on tape. Other devices, video capture capability is not confined to camcorders. Cell phones, digital single-lens reflex and compact digicams, laptops and personal media players offer video capture capability, but most multipurpose devices offer less video capture functionality than an equivalent camcorder. Most lack manual adjustments, audio input, autofocus and zoom. Few capture in standard TV video formats, recording in either non-TV resolutions or slower frame rates. A multipurpose device used as a camcorder offers inferior handling, audio and video performance, which limits its utility for extended or adverse shooting situations. The camera phone developed video capability during the early 21st century, reducing sales of low-end camcorders. DSLR cameras with high-definition video were also introduced early in the 21st century. Although they still have the handling and usability deficiencies of other multipurpose devices, HDSLR video offers the shallow depth of field and interchangeable lenses lacking in consumer camcorders. Professional video cameras with these capabilities are more expensive than the most expensive video-capable DSLR. In video applications where the DSLR's operational deficiencies can be mitigated, DSLRs such as the Canon 5D Mark II provide depth of field and optical perspective control. Combo cameras combine full-feature still cameras and camcorders in a single unit. The Sanyo Xacti HD1 was the first such unit, combining the features of a 5.1 megapixel still camera with a 720p video recorder with improved handling and utility. Canon and Sony have introduced camcorders with still photo performance approaching that of a Digicam, and Panasonic has introduced a DSLR body with video features approaching that of a camcorder. Hitachi has introduced the DZH-V584EW, with 1080p resolution and a touchscreen. Flip video. The Flip Video was a series of tapeless camcorders introduced by Pure Digital Technologies in 2006. Slightly larger than a smartphone, the Flip Video was a basic camcorder with record, zoom, playback and browse buttons and a USB jack for uploading video. The original models recorded at a 640x480 pixel resolution. Later models featured HD recording at 1280x720 pixels. The Minnow was a smaller flip video, with the same features as the standard model. The Minnow was the smallest of all camcorders, slightly wider than a mini DV cassette and smaller than most smartphones on the market. In fact, the Minnow was small enough to fit inside the shell of a VHS cassette. Later HD models featured larger screens. In 2011, the flip video was discontinued. Interchangeable lenses. Interchangeable lens camcorders can capture HD video with DSLR lenses and an adapter. Built-in projector. In 2011, Sony launched its HDR-PJ range of HD camcorders, the HDR-PJ 10, 30 and 50. Known as handycams, they were the first camcorders to incorporate a small image projector on the side of the unit. This feature allows a group of viewers to watch video without a television, a full-size projector or a computer. These camcorders were a huge success and Sony subsequently released further models in this range. Sony's current 2014 lineup comprises the HDR-PJ 240, HDR-PJ 330, HDR-PJ 530 and the HDR-PJ 810. Specifications vary by model. Uses, media. Camcorders are used by nearly all electronic media, from electronic news organizations to current affairs TV productions. In remote locations, camcorders are useful for initial video acquisition. The video is subsequently transmitted electronically to a studio or production center for broadcast. Scheduled events, where a video infrastructure is readily available or can be deployed in advance, are still covered by studio-type video cameras tethered to production trucks. Home video. Camcorders often cover weddings, birthdays, graduations, children's growth and other personal events. The rise of the consumer camcorder during the mid to late 1980s led to the creation of shows such as America's Funniest Home Videos, which showcases homemade video footage. Politics. Political protesters use camcorders to film what they believe unjust. Animal rights protesters who break into factory farms and animal testing labs use camcorders to film the conditions in which the animals are living. Anti-hunting protesters film fox hunts. People investigating political crimes use surveillance cameras for evidence gathering. Activist videos often appear on indie media. Police use camcorders to film riots, protests and crowds at sporting events. The film can be used to spot troublemakers, who can then be prosecuted. In countries such as the United States, the use of compact dashcams in police cars allows the police to retain a record of activity in front of the car. Entertainment. Camcorders are used in the production of low-budget TV shows if the production crew does not have access to more expensive equipment. Films have been shot entirely on consumer camcorder equipment. Academic filmmaking programs have switched from 16mm film to digital video, due to the reduced expense and ease of editing of digital media and the increasing scarcity of film stock and equipment. Some camcorder manufacturers cater to this market. Canon and Panasonic support 24p video in some high-end models for easy film conversion. Education. Schools in the developed world increasingly use digital media and digital education. Students use camcorders to record video diaries, make short films and develop multimedia projects across subject boundaries. Teacher evaluation involves a teacher's classroom lessons being recorded for review by officials, especially for questions of teacher tenure. Student camcorder-created material and other digital technology are used in new teacher preparation courses. The University of Oxford Department of Education PGCE program and NYU Steinhardt School's Department of Teaching and Learning MAT program are examples. The USC Rossier School of Education goes further, insisting that all students purchase their own camcorder as a prerequisite to their MAT education programs. These programs employ a modified version of Adobe Connect to deliver the courses. Recordings of MAT student work is posted on USC's web portal for evaluation by faculty as if they were present in class. Camcorders have allowed USC to decentralize its teacher preparation from Southern California to most American states and abroad. This has increased the number of teachers it can train. Formats. The following list covers consumer equipment only, analog. Low band, approximately 3 MHz bandwidth. BCE, first tape storage for video, manufactured by Bing Crosby Entertainment from Ampex Equipment. BCE Color, first color tape storage for video, manufactured by Bing Crosby Entertainment from Ampex Equipment. Simplex, developed commercially by RCA and used to record live broadcasts by NBC. Quadruplex Videotape, developed formerly by Ampex. This was the recording standard for 20 years. Vision electronic recording apparatus, an experimental recording standard developed by the BBC, it was never used or sold commercially. U-Matic Tape, originally used by Sony to record video. U-Matic S, a smaller version of U-Matic, used for portable recorders. Betamax, used on old Sony and Sanyo camcorders and portables. Obsolete by the late 1980s in the consumer market. VHS, compatible with VHS VCRs. No longer manufactured. Vhs-C, originally designed for portable VCRs, this standard was later adapted for compact consumer camcorders. Identical in quality to VHS. Cassettes play in VHS VCRs with an adapter. Still available in the low-end consumer market. Relatively short running time compared to other formats. Video 8, small format tape developed by Sony to compete with VHS-C's palm-sized design. Equivalent to VHS or Betamax in picture quality. High band, approximately 5 MHz bandwidth. U-Matic BVU, largely used in high-end consumer and professional equipment. U-Matic BVUSP, largely used in high-end consumer and professional equipment. SVHS, largely used in mid-range consumer and prosumer equipment. SVHS-C, limited to low-end consumer market. High 8, used in low to mid-range consumer equipment but also was available as prosumer industrial equipment. Digital DV, initially developed by Sony, the DV standard became the most widespread standard-definition digital camcorder technology for the next decade. The divide format was the first to make capturing footage for video editing possible without special hardware, using the 4 or 6-pin FireWire sockets common on computers at the time. DVC-Pro, Panasonic released its own variant of the DV format for broadcast news gathering. DVC-AM, Sony's answer to the DVC-Pro. DVD Recordable, a variety of recordable optical disc standards were released by multiple manufacturers during the 1990s and 2000s, of which DVD-RAM was the first. The most common in camcorders was Mini DVD-R, which used recordable A/C-M discs holding 30 minutes of MPEG video. DVHS, JVC's VHS tape supporting 1080p HD. Many units also supported IEEE 1394 recording. Digital 8, uses high 8 tapes. Most can read older video 8 and high 8 analog tapes. Micron, matchbox-sized cassette. Sony was the only electronics manufacturer for this format, and editing software was proprietary to Sony and only available on Microsoft Windows. However, open-source programmers did manage to create capture software for Linux. Blu-ray Disc, manufactured by Hitachi, HDV, records up to an hour of HDTV MPEG-2 signal on a mini DV cassette. MPEG-2 codec-based format, records MPEG-2 program stream or MPEG-2 transport stream to various kinds of tapeless standard and HD media. H264, compressed video using the H264 codec in an MPEG-4 file. Usually stored in tapeless media, AVC HD, puts H264 video into a transport stream file format. Compressed in H264 format, multiview video coding, amendment to H264/MPEG-4 AVC video compression for sequences captured from multiple cameras using a single video stream. Backwards compatible with H264 operating systems. Since most manufacturers focus their support on Windows and Mac users, users of other operating systems have difficulty finding support for their devices. However, open-source products such as Sinalera and Kino allow editing of some digital formats on alternative operating systems. Software to edit DV streams is available on most platforms. Digital forensics. The issue of digital camcorder forensics to recover data has been addressed. See also 3CCD, AVC HD, CMOS, flip video, firewire, charge-coupled device, due warning, picked bridge, PXL 2000 a a toy camcorder that used compact audio cassette to store video, pocket video camera, steady shot, USB streaming and USB port. VTR, professional video camera, references. External links, History of Camcorders by Mark Shapiro, How Camcorders Work from How Stuff Works.